instructional video is on writing equations of proportional relationships in the form of a graph. 1. Ada is growing sugar crystals for science class. There's a proportional relationship between the amount of water she uses, X, and the amount of sugar she uses, Y. So when we are referencing our proportional relationship and we're wanting to find the rate of change, we always set up our rate of change as a fraction, Y over X. So in this case, our Y values is our amount of sugar, and our X value is the amount of water, which is reflected in the graph. Cups of sugar is along the Y-axis, and cups of water is along the X-axis. When we are talking about graphs, we are also going to add in another version of this fraction called rise over run. So the sugar is our rise number and the water is our run number. Now, the first step we want to do is identify the points on our graph, and we're going to mark the points that we can read clearly. So my first point is at 0, and my next point goes to 4. To go from 0 to 4, that would be a positive 4 on our graph. And then again, to go from 4 to 8, that my next point's at 8. 4 to 8 is another positive 4 on our graph. When we go sideways, my point value is here at 0, and I would go sideways to the 1, so that's a positive 1 value. And then going again, positive 1 to positive 2 is also a positive 1 value. So our 4 is going to be our rise number. We rise 4, and we run 1. And so that's going to be our fraction that we make, rise over run. So we take our positive 4 and our positive 1, and then we divide our fraction just as we did with all of our proportional relationships so far. 4 divided by 1 is 4. So K is equal to 4, and we can write the equation Y equals KX as Y equals 4X. The Riverside Fire Department is hosting a fundraising banquet. There's a proportional relationship between the number of tables needed X and the number of chairs needed Y. So our Y over X fraction is going to be the number of chairs over the number of tables, which is going to reflect our rise over run fraction. So we're going to identify our points on the graph that we can read clearly, and then we're going to count our point values. 0 to 12 is going positive 12, and then we go over to positive 1. 12 to 24 is going up 12, and then over positive 1. 24 to 36 is going up 12, and then over positive 1. So our rise value is 12. Our run value is 1, meaning it's going to take 12 chairs per table. We set up our fraction as our Y over X, the rise number over the run number. 12 divided by 1 is 12, which represents our K value, the constant of proportionality. We use it to write the equation Y equals KX as Y equals 12X. Abdul is a lifeguard at Splash Central Water Park. There's a proportional relationship between the number of hours he works X and the total amount of money he earns Y. So Y over X is going to be reflective of our amount of money, and our X value is going to be the amount of hours, which reflects our rise over run graph. Plotting our points on the graph, there are several that we can read clearly. And so we're going to count our values. 0 to 10 is going up 10, and then we go 1 hour. 10 to 20 is 10 over to 2 hours. 20 to 30 is 10, and then over 1 hour to 3. 30 to 40 is $10. 3 to 4 is 1 hour. 40 to 50 is $10. 4 to 5 is 1 hour. We continue that pattern all the way across the graph, working $10 for 1 hour. Our rise number is the $10. Our run number is the 1 hour, meaning we work $10 per hour. Setting up the fraction, the rise number 10 divided by the run number 1 gives us a value of 10, which is our slope. And we use that number to plug it into our equation, y equals kx, making it y equals 10x. Number 4, Levi is renting a pedal boat at the lake. There's a proportional relationship between the amount of time he rents the boat x and the total cost y. So y is the total cost, and then x is going to be the amount of time that he rents the boats, which is going to reflect our rise over run fraction. Plotting our points that we can read clearly. 0 to 4 is $4, and then we go over 0.5 hours. 4 to 8 is $4, and then we go over 0.5 hours. 8 to 12 is $4, and then we go over 0.5 hours. 12 to 16 is $4. We go over 0.5 hours. And our last one, 16 to 20, is $4. We go over 0.5 hours. So our rise number is our $4. Our run value is the 0.5 hours. We set up our fraction with our rise number on the top and our run number on the bottom. 4 divided by 0.5 is 8. It costs $8 per hour to use the boat. So our unit rate is $8, which we use in the equation y equals kx to make y equals 8x. Having a birthday party at a laser tag arena, there's a proportional relationship between the number of people playing laser tag at the party, y, and the total amount of the cost, y. So we have our cost is our y value on top, and the number of people is our x value on the bottom, which is going to reflect our rise over run fraction. So again, plotting the points that we can read clearly. 0 to 40 would give us $40, and that would be for 2 people. Going from 40 to 80 would be $40, and again, that would be for 2 people. Going from 80 to 120 is $40 for 2 people, and we continue that pattern of $40 for 2 people. So our rise number would be the $40. Our run number would be the 2 people. 40 divided by 2 gives us a final answer of 20. It is $20 per person to play laser tag. So our K value, the rate of change, is the $20, which we use in the equation y equals kx to make y equals 20x. Eating ice cream sundaes for her friends, there's a proportional relationship between the number of ice cream scoops x and the number of sundaes y. So again, y is our number of sundaes, whereas x is the number of ice cream scoops. And it's going to be reflective of our rise over run fraction. So plotting the points that we can see clearly, we can make 1 sundae with 3 scoops of ice cream, 1 sundae for 3 scoops of ice cream, 1 sundae for 3 scoops of ice cream. So our rise number is going to be the 1 sundae. Our run value is going to be the 3 scoops of ice cream. And then we divide. 1 divided by 3 gives us a value of 0.3 repeating, which written as a fraction is 1/3, meaning we can make 1/3 of a sundae per scoop of ice cream cone, per scoop of ice cream. Our rate of change is going to be the 1/3 fraction, or the 0.3 repeating. We write it in the equation y equals kx to make y equals 1/3 x. Is knitting a scarf. There's a proportional relationship between the number of rows she knits, x, and the length of her scarf, y. So again, the length is going to be representative of our y value, which is the rise part of our fraction. And the number of rows that she makes is representative of x, which fills in our run spot on the fraction. Plotting the points that we can read clearly, she can do 1 inch, which would get her 6 rows. Again, 1 inch gets her 6 rows. 1 inch gets her 6 rows. We continue following that pattern on our graph all the way across. Our rise number becomes the 1 inch. The run number becomes the 6 rows. And then we divide. 1/6 is going to give us a decimal answer. You can choose to leave it as your decimal answer of 0.16 repeating, or you can simplify that to the fraction 1/6, meaning 1/6 of an inch per row of scarf. 1/6 is our rate of change. We add that to our equation y equals kx to make y equals 1/6 x. Last problem, Tyler is making frosting for his brother's graduation cake. There is a proportional relationship between the amount of powdered sugar he uses, x, and the amount of butter he uses, y. So again, butter is our y value, representing the rise part of our fraction. X is the amount of powdered sugar he uses, representing the run part of our fraction. Filling in the points that we can read clearly, he can use 2 cups of butter for 5 cups of powdered sugar. And that pattern continues, 2 cups of butter for 5 cups of powdered sugar. Our rise is going to be our 2 cups of butter. Our run is going to be the 5 cups of sugar. Dividing your values, 2 divided by 5 is going to give you a 0.4 fraction. You can leave it as the decimal, or you can write it as the fraction 2/5, meaning we can use 2/5 cups of butter for 1 cup of sugar. Two-fifths is going to be our constant of proportionality, which we add into the equation y equals kx to make y equals 2/5 x.